uh, errors that is occurred in the separating calorimeters and throttling calorimeter. So what we are going to study today, that we are going to study the combined separating and throttling calorimeter. We are going to study today the combined separating and throttling calorimeter. So as I have discussed, there are certain limitations of separating calorimeter. There are certain limitations of throttling calorimeter. Separating calorimeter cannot be used for higher dryness fractions, while throttling calorimeter cannot be used for the lower dryness fractions. So both these difficulties can be avoided by using the combination of separating and throttling calorimeter. So if you connect both calorimeters in a single unit, then that can be gives us the better results and errors can be reduced. So that is a combined separating and throttling calorimeter we can have. So what it consists? See, it consists the first part, that is a separating part. Okay, so same thing. See, we are not having any different part here. Only thing is that we are combining in the series, that separating and throttling is series we are connecting. So first part is their separating part, in which the suppose total mass of steam is coming ms, then that some part of the water is separated in the separating calorimeter, and the somewhat dry steam, or you can say that somewhat dry steam, is passed to the throttling unit. So here the mass of water is separated and mass of steam is passed to the next unit. In next unit, what you will do, you will throttle that, and you will measure the pressure temperature before throttling, pressure temperature after throttling, and then whatever the steam is coming, that is going to be condenser, so that it can be condensed and we can measure the mass of steam which is passed through the throttling calorimeter. So this mass of water which is separated here and mass of steam which is condensed here, the total mass is given the summation of these two. So total mass of steam can be given by the total summation of these two. So you can find out the dryness fraction using this, that is x1, and you can find out the x2 from here. So x1 and x2, if you got, the final dryness fraction can be written as x1 into x2. Okay, written as x1 and x2. So this type of the calorimeters are used for the very wet steams, particularly when you are having very wet steam, then you can use it. The first steam passed through the separating calorimeter and some part of moisture is removed due to the sudden change in the direction, and the resulting semi-wet steam is then throttled into a throttling calorimeter. So you can get the steam coming out of the throttling calorimeter is superheated at pressure P2 and temperature T2, and then this is condensed and its mass is measured. Throttling calorimeter is well insulated for that. So if you consider that mass of water, moisture collected in the separator MW, the mass of steam condensed after throttling MS, and x1 is the dryness fraction measured with the separating calorimeter, x2 is the dryness fraction measured with the throttling calorimeter, and x is the final dryness fraction, then you can have the calculation of x1 as mass of steam separated divided by mass of water plus mass of steam, and you can calculate the x2 because we are knowing the uh, temperature pressures before throttling, temperature pressure after throttling. With that you can calculate the x2, and you will get the final dryness fraction as x is equal to x1 into x2. So this is what the dryness fraction you can get from the combined separating and throttling calorimeter. Okay, so see now I want to explain you that in your mind the question may be there, why you are taking this x is equal to x1 and x2. So let us go for that.